Hello everyone, welcome to our channel Code with Sunny, and in this video we will be talking about the problem remove duplicate letters. Its index is 316 and it is the medium problem of the LeetCode. Okay, so without wasting our time, let's start. We would be involving the concepts of stack, that is how the elements that is being pushed right now will be present at the top of the stack, and how we will use the concept of the stack to solve this problem efficiently, right, in O of n time. Like we can have some other solutions also. I will discuss all those. You can see if you look out my submissions, I have 4 submissions, and the very first submission is quite looking very hectic to implement, but yes, I have implemented that. I will discuss all those in this video with the concepts that is being we are going to cover over there. Okay, so let's begin. Given a string s, and we need to remove duplicate letters so that every letter appears once and only once. That is, the frequency would remain 1 for every letter, like every distinct letter, and you must make sure your result is the smallest in lexicographical order among all possible results. Okay, if you are not getting this problem right now, no need to worry about. Let's reframe this problem. You need to consider all the distinct characters, right, and you need to find a subsequence of you need to find a subsequence among this given string that will contain all those distinct characters, right. Okay, so let me discuss this with examples also. First of all, let's look over the constraints. Max length of the string is 10 raised to the power 4, so you should be covering around open solution. That would be better. And the string consists of all lowercase English letters. Okay, so let's begin with this sample BC ABC. Okay, so we have this string as BC ABC. Okay, so first let's understand what this problem is going to tell us. It's like we need to consider first of all the distinct characters, that is character A, character B, character C. Okay, so these are all distinct unique characters, distinct characters. Okay, and we need to find a subsequence among this string such that we need to find a first of all subsequence, then we need to find out the minimum, like lexicographically smallest subsequence containing all these distinct characters. Okay, so let's first of all find out all those subsequences that is going to exist over here. So you can see we have a BCA, we can also have a BAC, like BAC, that is over here, and also we can have CAB also, and we can have ABC also. Okay, note that whatever the subsequences that I have chosen contains all those distinct characters that is present over in the input string. Okay, this one, this one, this one, this one. Now we need to report the smallest subsequence, like lexicographically smallest subsequence. So you can see the answer is this one. This is the lexicographically smallest. Okay, so you need to know the concept of lexicographically smallest string also among all the given n strings. Okay, so this will be our answer. Okay, so let's take another example over here, like this one. So let me just first change the color. So you can see I have the string as C, B, A, and then CDC, CDC, and we have then BC. Okay, so you need to choose a lexicographically smallest string such that it would contain all those distinct characters A, B, C, D. Note that these are the distinct characters that is present in this string, right? So you can see the lexicographically smallest string that we can choose is A, and we can have C, and we can have D, and we can have B, like A, C, D, B. You can check it out. This is the smallest, lexicographically smallest subsequence that we can choose that will contain all those distinct characters. Okay, now how to do that efficiently? Okay, so what we will do is, like, we will first reframe, we will introduce some linear vector that would keep track of the occurrences of element. Okay, so first let me erase this. Okay, so I would need this example also, so I would keep that. Okay, so what I will do is, like, I will first make this linear vector of size 26 that would map the character to the index. You can see I have named it at last. It means that I need to store the last index of that character that is present in the string. Why I'm going to choose this last index, why I'm trying to work upon this last index, I will tell you later on, because also you can understand it in simple ways that whenever we will try to choose a character, we need to check it out whether the remaining characters that we can choose after that or not. So that would be helpful in determine that that can be easily determined with the help of this last index of that character, all those characters. Okay, so you can see we need to choose a lexicographically smallest subsequence. So we will start with the character A. Okay, so when we will look out for the character A, wait a minute, let me fill out this last vector because I need to explain with the help of that also. So last of A will be, you can say 0 1 2 2. Note that I am using a 0 based indexing. Last of B will be 0 1 2 3, and last of C is 4. Okay, so let me write down the indexes also. 0 1 2 3 4, and I will be explaining this one also. Okay, so yeah, so we will try to choose starting from the A, because we need to find lexicographical smallest subsequence, right? So when we'll try to choose from A, I will first choose the first occurrence of that index starting from the beginning of this string. You can see from the beginning index A occurs at this position. Okay, so I will try to check if I will choose to take out this character A, I will be able to choose all those remaining characters that we have still not chosen, that is B and C. That is, if I will try to choose A, I must be able to choose the characters B and C just after that index. Okay, so last vector is going to help us in determining whether we can choose this character A, provided that all the remaining characters we are able to choose after that index, and that is the index 2. Okay, so if I will choose A at this position 2, you can see the last occurrences of B as well as C is strictly greater than 2. It signifies that yet yes, we can choose the character A. Okay, so what I will do is like I will append this character A to our answer. Now this A is discarded. I have I'm done choosing with this one. Okay, so next character that I need to work upon is the character B. So can I able to choose B? So what I will do is I will look out for the last character index that I have chosen, which is at position 2. So I will iterate after the position 2 and find the first occurrence of this character B. So it is present at the index 3. So can I able to choose this index 3 or not? So what I will do is I will check it out, whatever the remaining characters except B that are present and we are yet not chosen, and we can choose that character after the current index that we are working upon, that is the index 3. So you can see the character C has last occurrences as 4, present at 4, which is strictly greater than 3. So we can able to choose this character C later on also. Okay, so it means that yes, we can choose the character B right now. So this B is chosen, so I will append B to our answer and I will discard it. Okay, so last position is this one. So I will starting from the last position 3 that is greater than 3, I will first find out the first occurrences of the character C, which is present at index 4, and all the remaining characters except C, I need to check it out whether we are able to choose that characters after the index 4 or not. You can see when discarding C, there is none of the distinct character that is present over there, so we can choose C. Okay, so this is the lexicographically smallest subsequences that we are going to form. Note that why it is lexicographically smallest subsequences, because we are starting from the smallest character, right? So this will give us the smallest subsequences. Okay, now we need to check it out for this index. So I need to first fill up the last values of all those positions. So where I can do that? So let me write down over here last of this A, you can see is present over here, which is 2. So last of B, which is present over here, which is 6. So last of C, which is present over here, I will write down 7, and last of D, which is present over this position 4. Okay, so let's try to fill out the answers. Okay, so I need to start from the character A, right? So for the character A, I will start from the position 0 and find out the first occurrence of this A. You can see first occurrence of this A occurs at index 2. Okay, so I will append this character A to our answer only and only when whatever the characters except A we can choose after the index 2. What how we are going to check that, like all the characters last indexes must be greater than 2, strictly greater than 2. You can see 6 is greater than 2, 7 is greater than 2, 4 is greater than 2. So yes, I can choose this character A, so I will discard this A. Yes, it is chosen. Okay, now let me look out for the character B. Okay, so starting from the index 3, because we have chosen this index, like we have chosen the character A at the position 2, so I will start from this 3. I need to find out the first occurrences of the B starting from this 3. Okay, so you can see B occurs over here, that is at the position 6. Okay, so B occurs at the position 6, so I will be able to choose B only and only when all the characters except B, that is the C and D, must have their last occurrences greater than 6. So you can see 7 is greater than 6 but 4 is not greater than 6, so we are not able to choose B, so I will not choose B. Okay, so B cannot be chosen over this position. Okay, so can I able to choose the next smallest character, that is the character C? So let's check it out. Starting from the index 3, find out the first occurrence of the character C. You can see C is present over this position 3. Okay, so all the characters except C, that is the B and D, must have this their last indexes greater than this 3. So you can see 6 is greater than 3, 4 is greater than 3. It means that yes, we can choose the character C. So C will be discarded and yes, I am able to choose C. Okay, so in the next step again we will start from the smallest character, but we will start from the character B because we have chosen the C. So can I able to choose B right now or not? So B occurs at this position 6. Okay, so I need to check it out whether we are able to choose the character D or not, but D, you can see D has the occurrence as 4 and this should be greater than 6, so it is not possible, so B cannot be chosen. So the next smallest character I need to check is D, so I should pick up this D, and similarly you can check it all those, you will get the answer as ACDB, I think. Yes, if I will look at this one, you can see ACDB is the correct one. Okay, so this is the sequence of steps that we are going to do. If you look at my submissions, I have one of the submissions being accepted over here. That is quite hectic to implement because yes, I need I have taken some time to do that. So what I've done is like taken an string's length and previous as -1, and this will store the last occurrences of every unique character. Okay, so I've taken this answer and I have implemented a while loop, that is an infinite loop, and we need to stop when this boolean variable is remains true at the final. So each time I will try to pick up start with the smallest character. If that character is int max, it means that yes, it is chosen. It means that yes, this distinct character is chosen. Otherwise we will start from previous +1 index and I will find out the first occurrences and this will be stored in the index. Okay, so I will mark this boolean variable done as true and start with the smallest A and goes to Z, and if all the remaining characters which is not chosen, like remaining distinct character, if the last occurrence is smaller than the current index, we are not able to choose the current character, which is the character CH. Okay, so if done becomes full and we need to break. So if done remains true, it means that yes, we are able to choose the smallest character CH. So we will make a stop as false, that is we need to move out to the next condition, next step to choose the smallest character, and we need to also push back the character CH, change the previous index, and also this last occurrence make it to int max because it is chosen right now and we need to break. So if stop remains true, we need to stop this while loop. So this will give you all test cases passed, but you know the complexity is not good, so we need to do something better. So we are going to move out to the stack based solution. Okay, so how we are going to use the concept of stack to solve this problem efficiently. So let's try to understand that. So let me just erase all this one. Okay, so that would be better if I will keep some information, that would be quite helpful. Okay, so let's try to understand how stack is going to help us to solve this problem efficiently. Okay, so what I am going to do is like I need to write down the characters like push out the characters efficiently, and we'll try to find out the lexicographically smallest by iterating it directly. Okay, so how, let's try to understand how we are going to do that. Suppose we have this string BC ABC. Okay, so the first occurrence is B. Okay, so I will push out this into my answer, and next smallest next character is C. Now you can see B is greater than C. Okay, so still the lexicographically smallest criteria is valid, because you know B is smaller than C. Suppose we have the character BA, so there might be possibility that we should choose A, then we should choose this B later on, right? So but we have this B and C right now, so we will push out this directly into our answer. Now comes the character A. Now here is the tricky point. So when A comes, what you will do is, like, you will compare the characters at the top of the stack of your answer, which is the character C and the character A. Now you need to pop this out. Let me write down: pop out character present at the top of stack, present at top of stack, when we are going to pop this character out when this character can be taken, like we can take this character later on, when this character can be taken later after the current index, then we are going to pop this character out, because you know A is lexicographically smaller than C, so putting A earlier is quite a good option, right? So what I will do is, like, I will check it out the last occurrence of this C. You can see last occurrence of C is 4, and still A is at this position, which is at the position 2 if you consider zero based indexing. So it means that yes, we can choose this character C later on. So what I will do is, like, I will pop out this character C. Okay, so, and put A over here. Again we will compare this B and A. So you can see B has the last occurrence greater than the position 2, which is the current position of A. So we will pop this B out as well. So my stack would contain only the character A at the top. Now comes the character B. So you will insert it, push it directly, and the character C. Now this is the lexicographically smallest. Okay, so let's consider the example case for this one. Okay, so let me just okay, so we are talking about this one right now. So we have this character. So okay, so we will start from the character C. Okay, we have this C. Now comes the smaller character than C, which is B. So we will compare the, you can see whether we can cover this character C later on, that is after index 1. So we will look out for the last index of C. Last index of C is 7. So yes, we can cover up this one later on. So we will pop this C out. Okay, so my stack would become the character B. Now comes the character A. So we will check it out, the comparison between B and A. Okay, so when we are comparing this B and A, you can see that B can be covered later on, which is 6, and the current position is 2. So we can pop this B out. So my stack is only A. Now we will look out for C and D. So you can see both C and D are like this one. Both are like greater, lexicographically larger than their previous character present at the top of the stack of your answer. So A, C and D will be pushed directly. Now again comes the character C. So you're not going to compare it, because you know C is already present in the stack and this is already lexicographically smallest. Okay, so we are not going to compare C with this one. Okay, so we will look out for the B again. You can see when we look out for the B, you will pop out this character D only and only when D can be covered later on after this index B. Now index B is 6 and the last occurrence of D is 4. It means that all the D's had been exhausted. So you cannot pop this D out. So what you will do is you will push out this B directly. Now comes the character C. Now C is already present in the stack, so you're not going to do any operations over there. So this is your answer, ACDB. So if you look at the answer, ACDB is the correct answer. So let's look at the implementation, how we can implement that efficiently. So we will be having O of n time and O of n space code. Yeah. Okay, so we will be having the answer and n as strings length, and last and visited will check it out the last occurrences and whether we have visited this character or not while implementing the stack solution. So you can see I've iterated for the n times, and when the any unique character is already present in the stack, we are not going to move further. Otherwise, mark its occurrence in the stack, because we will push out the character last, at the last of this operation. Okay, so while answer is not empty, while we have a non-empty stack of your answer, and we will compare the current character with the stack stop character, which is answer back. And you can see if we need to pop this character at the present at the top of the stack only and only when its last occurrence is going to be greater than the current index. That is, we can cover this character later on. Okay, we can cover this unique character later on, right? So if we are able to do that, we will mark its occurrence as false in the visited vector, because we are going to pop it out and we need to cover it later. So we should make it as false, right? So that later on we are able to process that character, and we are also going to push back the the current character s of I at last when this operation has been done. Push out in the stack of your answer, and finally return the answer. This will give you all test cases passed. So if you guys have still any doubts, you can reach out to us through the comment section of the video, and thank you for watching this video.